Current crowd simulation research often looks stale and unrealistic because agents fail to socialize naturally with each other. Some recent work has tried to create crowds that interact socially, but the results are limited. Current results are often unrealistic since agents cannot enter and leave the conversation as needed. Results are inflexible since they depend on a specific obstacle avoidance algorithm, or they are not expressive since they cannot be artist directed. We propose a new social crowds algorithm that addresses these issues. Our approach is realistic since agents move in and out of conversations naturally. To do this, we use principles from the area of psychology called transactional analysis. Our approach is flexible since it is not constrained to a specific obstacle avoidance algorithm. And our approach is expressive since it allows for real-time artist direction to determine the social environment. Shown here is a path in a park. The results in this shot were generated without our algorithm. Notice that the agents avoid each other, but they still appear unrealistic since they don't stop to socialize. This shot shows our algorithm in action. Notice that agents stop to talk and pair walk. Conversation is noted by the black words above each agent. Shown here are agents in a 15-story building. Again, without our algorithm, the agents do not show the natural socializing we would expect to see in an office. Notice that the addition of socializing creates natural clumping of agents that would not otherwise be present. This global effect greatly increases the realism of the crowd simulation. Similar results are shown on this globe. Without our approach, the movement looks unnatural. With our approach, natural pairing off occurs, creating a more believable crowd. Notice again the more realistic global dynamics resulting from our social algorithm. We now look at the specific features of our approach. Our approach uses the area of transactional analysis to alter conversation lengths based on the past history of encounters. Shown here, two agents meet in a hall and have a long conversation. Not much later, they meet again and have a shorter conversation. Meeting again, they don't stop to talk since their interest has waned. Notice that this pattern mimics what we would expect to see in real life. Much later when they meet again, their interest in socializing has returned, and they again talk for a long time. Our approach is flexible since it allows for almost any obstacle avoidance algorithm while still producing realistic effects, like agents stopping to talk and pair walking. The following shot shows our algorithm running on top of three different obstacle avoidance algorithms. First, we show results from reciprocal velocity obstacles. Next, we show results from social forces. Last, we show results from an anticipation algorithm. Shown here are two agents that are pair walking in the same direction. The one in front waits for the one behind and slowly begins walking as the one behind catches up. Notice that our algorithm handles this without altering the underlying obstacle avoidance algorithm. After they walk through the crowd together, the direction to their destinations diverges. The agents then part ways naturally. Our approach is very expressive since it can create a variety of social scenes in an artist-directed way. In this scene, we use the artist-directed nature of our algorithm to create a party environment. The highlighted agents are the partygoers, and they socialize with other partygoers. The gray agents are the waiters, and they do not socialize. Notice that this creates a much different social environment than our earlier park scenarios. As this scene shows, making changes to the social environment with our algorithm is very easy. Shown here is an office scenario. We simulate a fire alarm using a simple button to reduce the global conversation interest. When the all clear is given, again by using our real-time controls to increase the global conversation interest, the agents resume talking. This type of real-time artist direction makes our algorithm very unique as compared to previous work. We have presented a new social crowds algorithm that is more realistic, flexible, and expressive than previous work. Thank you for your attention.